best possible watershed you can get. So the entire complexity of the SWAT model, if you look for the watershed.
Right, I need to talk a bit more about HRUs. So I'm going to look at right, I'm going to select the full HRUs shapefile. You don't need to do this. You just need to look at the screen. Okay? It's more important that you look than try and do this. I'm not going to do anything complicated, but I'm going to fairly arbitrarily select done this the wrong way around. I should have looked at the number. 579, isn't it? So where's HRU 579? Oh, let's just choose a number.
Yeah, better you choose.
It's better to do it this way around.
Yeah.
Okay. So just selected one HRU. Right? Now an HRU is within a particular subbase is a combination of a particular land use and a particular soil and a particular slope range. And it's all the pixels that have those properties, right? So it's not a contiguous area, right? It's just all the pixels that have those properties. Now in the model, it's as if that was one, right? Because the small model is going to compute values for every HRU and then combine them by collecting all the HRUs in that landscape unit and then collecting all the landscape units in that subbasin and then all the subbasins. Okay? Sorry?
Each subbasin or
Yes, within each subbasin.
within?
It goes from HRU to landscape unit
Yeah.
to subbasin to watershed.
So to give the returns within the updated.
Yes, so when we look at results tomorrow, okay, you'll see there are numbers for HRUs, there are numbers for landscape units, there are numbers for subbasins, and there are numbers for the whole watershed.
How do we know that how you are doing correct? Okay, how we can deliver it right?
We will use some of our but who is watershed? Soil check.
Yeah, I'm talking about soil check tomorrow.
Yeah, we will talk about tomorrow. So we will see a summary how our watershed is performing in a very good way, a user-friendly way. And if those numbers make sense,
Yeah.
like they are not very abruptly. If they make sense, then you get to know, okay, you did something right. Okay, so we will do that one tomorrow.
Yeah.
Excuse me, how did you open this table with?
Oh, sure. This one is he just opened the attribute table of this shapefile.
To open the attribute table, you right click on the entry in the legends panel, and then you say open attribute table. Okay?
So one thing I did not mention into theory part was how SWAT handle computation. For example, now you divided the entire watershed into small units. If you see the actual individual field of corn or individual field of agriculture. So if SWAT calculate for each of that, it would take a lot of time. So what it did in a sub-basin, each of this pixel shares the same information. So it merged all the pixels into one HLU. Okay. So rather than having one HLU here and one HLU here, one HLU here, so three, rather than having three different HLU, it combined because they share same land use, same soil, same slope class. So it combined that it said, SWAT assume that they are going to behave same all the time, right? Entire physics behind those three are same. So that's why it combined all these three different land locations into one HIU and now calculate the one time. So rather than three times, so it's calculating one time. So that's how SWAT optimized on the computation. So you will get your results sooner than otherwise. Maybe one day just to run the model, but this way just like a few minutes to run the model.
Right. So if you look at the, perhaps I should need to expand that. Try. Right, here we are. So this is the attribute table. So it says the channel number is 22. It's the upslope. Now, if you notice, let's define it. It's in two pieces, right? Some bits on one side, some bits on the other side, because the upslope, remember, is the opposite of the floodplain, right? So the floodplain LSUs will be somewhere in this area, right? The upslope is either side. Well, the floodplain is either side as well, right? So typically, you'll get some of the HRU on either side of a channel. So you can't really say, where is that HRU, right? There is positional information because you know it's going to drain into that channel, right? And you know it's an upslope HRU, so some of its water will actually go to the downslope landscape unit, the floodplain landscape unit. But you can't say more than that roughly where this HRU is. Okay, that's one thing I wanted to show you. Now, if I switch the view to the actual HRUs, oh, sorry, there's one thing else I forgot. That HRU has actually got two HRU numbers, right? It was originally AGRL, because that's what's recorded as the land use. But it actually is now two HRUs. It's 50% TEF and 50% corn. So HRU number 271, we'd have to look in the other output table to see whether that was TEF or corn, and 273 will be the other one. All right, it's not even one HRU, it's two. But again, you can't actually do the division. You don't know where the corn and the TEF are. You just know they're somewhere around there, and it's going to contribute to that. You know, the outputs are going to contribute to that landscape unit, and its water flow will be to that stream. So that's all you know. Okay. Now we're looking at, so the full HRUs was before we did any subtraction. The actual HRUs is after we've removed the small ones, and we get some holes. Apparently there's no HRU here. So what's happened? All right, what's this hole? What you can see underneath is the blue of the DEM, the green of the DEM. All right, well, what's happened is some HRUs have been removed and the others have grown. All right, but all I can do is draw sort of boxes around pixels. So I can't show you how the rest have grown. All right, so the actual HRUs map is really not terribly useful. There's someone, Song-Yu was reminding me at lunch that he actually needs it for something, so someone found it useful. Right, any questions? Right, well, it looks like we're going to be running a model today.
Yeah.
So I've finished for now with QGIS, right? So the purpose of QSWOT, which is a bit of run from QGIS, is to extract geographic information, positional information, right? So I've calculated where the HRUs are in this precise enough to say which channel they flow into. And there's also details in the database now that channel 22 flows into channel 21, which flows into channel 49, which so on, right? So I've got enough information, all these stuff, extracted all the information I can get out of maps. So that's what QSWOT Plus is for, is extracting map information.
Yeah.
So what are we still looking? Well, what inputs are we still lacking? It's just one. One climate, sorry?
Climate. Yeah.
Climate, yes, climate. So that's what we're going to do next, is add our climate information.
So on this last comment, so QSWAT Plus is not SWAT Plus, right? QSWAT Plus is GIS interface to set up a SWAT Plus model. And the SWAT Plus model is actually executable. When you created this folder, you got some executable installed, and that executable is actually the SWAT Plus model. That executable have all those equations about nutrient, runoff, and everything. So that executable is model, not the QSWAT Plus. So some people get confused. So for example, I don't, if maybe when you keep working with the SWAT Plus, so you may not need the QSWAT interface after developing it. You can play with the files. Okay. So now we are done with our first tool. Now we will go to our second tool, which is editor. And then there is third tool, SWAT toolbox. So these are to assist our model, SWAT Plus model, but they are not model itself. The combination is, you can say, entire model. So we'll go to our second tool.
Right, I'm going to do one thing first, which I don't want you to do. Just watch. Good at that. So I can, if it was tea time, I would click OK, right? And what that does, but obviously remove that form. It also saves the model. So you never get reminded you haven't saved. If you click OK, it's saved. So when normally QGIS will come up with, are you sure you don't want to save any changes? Right? And now if I start QGIS again, find it, there it is. And it decides, oh, I thought you'd finished for the day. I've gone home. Grief, it's slow. Right. Come across. Right. First of all, the one I just run is in the recent projects. So it sits there, or else you can there's also a recent projects entry under files, open recent, it says, and good grief, yeah, I've run a lot of things, right? But it's at the first one there, so if you double click on that thing, it will come up, and it remembers everything, remembers exactly what you were doing, right? And if we open QSWOT Plus, then it says you've done delineation, you've done create HRUs, you can run the editor. Right? There's actually a fourth item which is not there, and that's because we haven't done enough to make that visible. We'll see it tomorrow. Okay, but we're back exactly where you were, right? Even the map view is the same. Right? And all the options you chose. Right, like the thresholds for the stream, thresholds for channel, the selection you made for the slope ranges, the selections you made for HRUs, they're all stored and restored when you start it again. Right, so what I want you to do, if you can see what I'm doing, is click on Edit Inputs and Run SWOT. And this is where the SWOT editor starts. So it says, so you haven't opened this before. This is incidentally all down to Jacqueline at the back. Right? So anything that goes wrong now is Jacqueline's problem. Right. So it says this is the project you want. You can say, no, I want to look at another project. That's all right. You can change this name, but we leave it there. And I'm not going to describe our project, but you've got a box for that. You've got something called SWOT LTE, which I know nothing about. We're not going to use it. So what we need to do is to click Start. That sounds like a good way to start, doesn't it? So please do that. Yeah. And it makes some more tables in the database. It makes the tables that Jacqueline wanted rather than ones I wanted. Right, so it brings up the initial view of the SWOT editor. Go away. Right, so it's got a few summary facts, how many HRUs there are, how many channels there are, and this land use soil distribution is a pie chart, which shows it's mostly corn or teff, right? Little bit of forest, the dark blue, and some pasture. Right, so we're reminded what it looked like roughly, and there's some statistics, and it's got a simulation period. I don't know how it got that. I think it just invented it.
Yeah, this is by default.
Yeah.
Yeah,
Yes.
we have not decided anything.
Yeah. No. Right. So what are we going to do? We look at the first. On the left here, we have possibility to edit SWOT plus inputs, and that's what we're going to do. So you select that, and right at the top, because it's the first thing you do, is climate. And we're invited to do two things. One is to say, what's the weather generator? Remember, Aaron said the weather generator is a statistical tool. You know, it gives the probability of it raining tomorrow, if it rained today, and so on. And that will invent data if there's any missing. Or if we have no humidity data at all, it will generate that for us. Right? And some people say, if I've got complete data, why do I need weather generator? Well, the answer is you do, because the tool is written that way. So you click on weather generator, and it says you've got nothing available yet. So we can do it by hand, which would be pretty tricky to do. We import data, that's what we're going to do. So we click on import data, and it says you've got two choices. One is you can use a database. Okay, and if you downloaded, as you were given the option to, the weather generator for SWAT from the website, then that's what you choose, and then it will find the nearest pseudo stations in that database for your location. Okay, it knows where you are because that information was connected from QGIS. Or there are two formats you can use, two CSV files or one CSV file, and the details are in the documentation. But the Robit data, it has the two CSV files form. So select two CSV files, right? And there's a reminder of what you need to be having these files, but it's already sorted out for Robit. So I'm going to go to, I hope, the Robit, right? The example data sets Robit folder, same place as we keep going. And down here we got WGN Robit Mon and WGN Robit Stat. Okay, these are the station data and the monthly data that we were asked for. There's also the single file format, so you can see an example of that if you wanted to, if you ever need it to copy the format. So for the stations file, it's the lower one with stat in its name. So we select that and open it. And then we go down to the second one, which is the monthly values. And then we select WGN robitmon.csv and open that. And then because we've got observed data as well, we're going to check the button at the bottom, because then it will use the observed stations. It will just make weather generator form data for each of our observed stations. Okay. Right. And then we say import data. And we see we've got a single line, because it's generated one station for the time, longitude, and it's got a supposed elevation, and it's got some, it's based on, it shows the statistics was based on 10 years. Okay, so that's the weather generator done. Everyone managed that, except the people being helped. Okay, so now we click on the weather stations. And again, we've got some data to import. Right, and as always with this tool, there's more than one way of doing it. So there's old format and new format, basically. All right, the SWAT 2012, which is also, if you go to the SWAT website, you discover that if you put in your latitude and longitude for east and west, north and south, like a box details, and say, please give me weather data for some period, you also tell them, they send it to you for free. Right? And if you ask for it that way, then you get it in this format, first format. And for the Robit example, it's also in this format. I'll show you what the format is. So that's what we choose. Right, then it gives you two options below. One is where the data is coming from, and this is where I'm going to store it. And normally you store it in this default folder, the text in out file, which is where all the input data for SWOT or SWOT plus goes. So I click the first of the file symbols. And all you have to do, once you've got your data all sorted out, is give it a directory, and it's Climate Robit. I'll show you in a second what that contains, what I'll show you now. So Climate Robit has got, because it's got a select folder, sorry, forget that. Just select folder. I'll show you separately what, right, so the folder is example data sets, Robit, Climate Robit. So you just select that folder and you select import data on the right, and it reads it and it creates one station with precipitation data and temperature data and solar radiation data and humidity data and wind speed data. I can't see at the moment. Oh, and the latitude and longitude, right? So in this case, there's only one weather station. We've only got, well, it's a small area. There can be many weather stations. Each will have its own latitude and longitude. And then what SWOT will do, or SWOT Plus will do, is take the nearest weather station to the centroid of each subbasin. Right, so if you have several weather stations, they will get chosen by that algorithm. And I'll show you what you need to set up to do that. If I look at Climate Robit, if I can find it. Needless to say, it's somewhere else than where I am at the moment. There we are. I clicked twice there and made a mess. Let's enlarge that. So this has got two kinds of files in it. It's got files that tell you about the details of a station, or maybe of many stations. So if we look at PCP, it must be called pcp.txt. Right? I had someone report an error recently. It won't import the climate data. It turned out he'd named this file hm.txt instead of hmd.txt. Right? So you have to be careful and check you've got the details right. So what does pcp.txt look like? Right. Again, I lose the edge. It's a CSV file with what, five items on each line. There's only one line because there's only one station. Right. So the first line value is a number, which is just off the screen, a name, its latitude, its longitude, and its elevation. Okay. The important thing is its name. Right? If this file has a line with Rob PCP in it, it means that in the file, there must be a file called robpcp.csv. Okay, if there were two stations, there must be two files. And these contain the data, the precipitation data for that station. So if we look at what this one looks like, again, it's a CSV file. I can't see this one at all. Because I can't see the left-hand edge. Oh, I can this time. Right, so there's a date at the beginning, which for some reason is written just with numbers, and it has to be in that order. All right, year, month, day. And then just values. All right, so this is obviously a lot of dry weather. Okay, so precipitation, you have to look in the documentation to see what the unit, I presume this is millimeters of rain. I wouldn't, but don't take me. So sometimes it rains a lot, we've got 63, but anyway, there's just a value for each day. Remember all the climate data, unless you're using the options to do sub-daily, and even if you want monthly output, the data is always daily. So that's what a precipitation file looks like. So we've got pcp.text for precipitation, tmp.text for temperature, HMD for humidity, SLR for solar radiation, WND for wind speed, 5. Remember, only the first 2 are compulsory. The others can be missing, but don't misspell them because it won't get used. Okay. Right, so that's what climate data looks like. So this is unusual and only having one station. Right, so now we've done the weather generator, we've done the weather, we can run it. So go to the next symbol on the left, because we're not going to do anything complicated with this model today, we're just going to run it in its basic state. So I'm going to click on the Run SWOT Plus button. You think it's going to run? Well, not quite. So it comes up with a new form. Right, so it says, where do you want to write your input files? Well, just write them in the default. Everyone writes them there. Right, it's under scenarios default text in out. What's our simulation period going to be? Remember, it started by saying it was 1980 to 85. Well, actually, that was before it knew. It's now looked at our weathers files and decided they are 14 years long. They all start with the same date. If they started with different dates, it will adjust for that, but it will be an odd thing to do. And it just looks to how long they are and calculates this is going to run from 1990 to 2013. I'm not going to run that long. So let's adjust that. You can edit these dates. I'm going to run from 1990 to 2000. Right? No particular reason except that it takes time. I'm going to run it for 2013. You can do it as your homework. Okay. And right, that's all of that. I don't need any advanced options. The next thing I'm going to do is look at the print options. The one important print option is the first one, warm-up period. When you start the SWOT model, your soil is dry, your reservoirs are empty, nothing's been sown. So it's not a typical year, this I've got. So what you do is you let the model run for a while, get the reservoirs full, get the crops that you can harvest, whatever, all sorts of things I expect. But you want to get it into a typical state. Right? So, but this is not a sort of run option, it's a print option, because this tool has to run for those first 1, 2, 3, 4, 5 years, but they have to be excluded from the output. You want to know what the typical and the temp output is, there's no point including the warm-up period because it will not be typical figures, right? So all you're doing is excluding what's going to get output as data or printed as data. That's why it's called a print option. So we've only got 11 years because I've shortened it. So let's use 3 as the warm-up period. Right, so the default 1 is almost certainly too low, so we'll use 3. Okay, and then we've got the yearly output, annual average output, which are all chosen as default. But I'm going to choose monthly output. I'm just going to select all of them. Right, there's a convenient button at the top that allows you to select all the possible monthly outputs, even though most of them I won't look at. Okay, I don't need any advanced options. I want to write the input file, so I'll leave that checked. I want to run SWOT, and I'm going to use the default version. I have no reason to go to an older one, and the newer one isn't available. And remember to tick the bottom box. What the bottom box means is that, well, a tool called SWOT check will be available, but more importantly, it'll write all the outputs into a database. SWOT is a very strange tool because it only uses text files as inputs, and it only writes text files as outputs. Text files are not a lot of use. It's like, so the tool we're going to see tomorrow on visualization uses a database containing all the outputs. So unless you check this bottom button, that tool won't be available. Right. I don't know what you do in Korea, but in England we cross our fingers to hope something works. So whatever you do in Korea, you can do, or in your home country. So I'm going to save settings and run selected. I was once teaching a course in Brazil. We were very good wanting this. It was on theorem theory. And someone put up their hand, I can't get this to work. And I go, oh, you do this. And they say, oh, well, the computer knows it's you. Right, so it's loaded we've written the inputs needed, and it's now running SWOT Plus, so it's done 4 years. You see why I didn't want it to run for 20. It runs much slower on my laptop than on my desktop. Anyone finished yet? Got past the laptops to mine? No.
I had a problem with the communication.
Yeah, what's all? I tell you, I'll show you. The first step was completed. It's creating lecture, but then you can have
Well, if you've got the wrong user, so example.
Okay, wait. Very good.
There's a lot of
Yes, so. Yes, global countries, they have I'm not sure about Korea, but in the US, we have many bases. One is preparing the mental maps, then this one is some of the resources, but Korea specific, I don't know. But I have some colleagues, like, they have the teaching, some you is teaching. They want to go straight from.
immediately done that.
You have.
Right, so it's now importing, sorry, it's reading its outputs and writing those files to the database.
Because you have slow computer.
I do have a slow computer.
Everyone else is.
That's because I haven't done it, you see. Well, you just have to tell Streety to get me a new one.
Yeah.
Oh, this is quite old. I mean, some of the keys now,
Yeah.
the number keys don't work after the time.
We should be.
Very cheesy. Trying to put very values in and get them. You never know whether the key is going to work or not. When it was bought, it was quite a high specification, but yes, it's slow.
Yeah.
Still, it goes for being old, you see. I'm still
Okay. Anything about weather data or warm-up period, simulation period, any query, question about that? No? These guys are expert, right? Usually I get a lot of questions on these steps. You're explaining good. Okay.
Here, here's the.
Okay, okay. I'll just. Sorry, your knowledge.
Oh, it's finished. Okay. So there was a question earlier. How do we know it makes sense? Right? We've done a lot of stuff relying on tools. It's produced a lot of outputs. Does it make sense? Can we rely on it? So there's a tool called swap plus check. So I want you to click on that. And it won't start. Why doesn't it start, Jacqueline? Oh, kick it again, and it did start. So swap plus check is just a sort of sanity check. Does this data make any sense? Does it look reasonable? First of all, there's a page that says, don't take this as serious criticism. It means nothing more than you might like to look at. Right? It doesn't say this is wrong. Okay? Because it's just saying, is this what usually happens? Okay, but it doesn't know about what Ethiopia is like, right? It doesn't know more about growing tech than it's in the data. It doesn't know anything about your watershed, really. It's just saying, it's these the sorts of results you would probably expect. And everyone ignores that and says, I get errors. Right? So it's got a whole lot of pages we can look at one at a time. One's listed on the left here. So the hydrology, it comes up with this blue panel. You think, oh dear, I made a mistake. No, it just says your surface runoff ratio is quite high. Do you think that's all right? Well, yeah, that's what my soils are like, or the slopes. You know, a lot of it is very hilly. That's what you'd expect. The groundwater ratio may be low. Lateral flow is greater than groundwater flow. Surface runoff may be excessive. I guess some of those are really saying the same thing. Yeah. So they're not errors, right? They're just saying your watershed is a bit unusual compared with the average watershed. Yeah, it's not an average watershed. This is my watershed. So you can look at the numbers. It tells you what's the, I don't know what that figure is. Is that average annual?
Yeah, these are the average annual values, like over the time period of 1990 to 2000. It averages out the numbers, precipitation, ET, and spit out these information.
Right. And if you go to the sediment page, there's nothing to say at all. Right? But again, it will tell you what the numbers are for your
Annual average.
the annual average again. Yeah.
The numbers of this one is annual.
Right. So the nitrogen cycle, again, there are no comments. It's happy with that. Phosphorus cycle, again, lots of numbers, but no comments. Unusually low phosphorus stress. Right, it's the only remark it makes about plant growth. And so on. Okay.
Somebody asked this question earlier, like how we are gonna check the numbers are making sense or not. So this gives you the annual average numbers. You should know about your watershed. Does that make sense? For example, it gave you the warning that there is unusual, very low phosphorus stress. So you should know your soil. Like, does that soil have enough phosphorus without any kind of fertilization? Can it hold that much? So those kind. So it will spit out some warnings and those numbers. So
Okay. It even got a box about reservoirs, and it complains there is no reservoir data, which is not very surprising because there weren't any reservoirs. Okay, any questions about SWOT check? You want to go to hydrology?
Yeah.
What do we do? Enlarge it?
yeah. So this is how much precipitation you have annual average on your watershed. How much go to the evapotranspiration, but you also get the potentiality numbers. And then, because we are running at daily scale and how much surface runoff, average current number based on your land covers. Because we saw that most of the land cover was agriculture, and in the agriculture, the current number ranging between 70 to 85. Okay, the higher the current number is, like higher the surface level. Okay, so impervious surface, urban surface, that would have current number of 99 or something like that. Water would have a curve number of 100. And agriculture, 70 to 85. Forest, less than 70. Because our watershed was dominated by the agricultural land, that's why somewhere near to 80. Okay. And that's why surface runoff is quite high, like around 40% of the precipitation. And then some numbers, what is happening to the environment. So this is summary. SWAT check gives you summary only at the watershed scale and annual average value. Like over the time period, what was the average values? We have all the outputs generated in our folder, which we will see tomorrow, I think. Tomorrow or today? We want outputs files.
You want to look at them?
No, if we have time, we can introduce some of the output files.
Yeah.
Yeah, so, but all the outputs, whatever you need, like we selected monthly scale and a different at HRU scale, sub-basin scale, and watershed scale, those are saved into your folder. We will see those numbers over there. So SWAT check is just to get an overall idea that everything is working or not, or makes sense, and then you can keep. So any question on the SWAT check side? Multiple.
In particular, let us stay in the benefit generator. What kind of, the SWOT gives you the average value.
So if you have multiple stations, so what SWAT would do, so for each sub-basin, it use one station. So if you provided multiple stations, based on, it will calculate the centroid of that sub-basin, and whichever is closest to that centroid, it will pick that by the station.
So simulate automatically pick the one, the closed one?
Yes, the closest one, it will pick the closest one,
Oh,
based on the centroid of that sub-basin. That's a good question. Any more questions? Yes.
Two questions in diagonal cycle,
Like-
they are diagonal cycle.
Yes.
They are, of the difference between NA and N0, and how can I interpret the bias value?
Okay, let me see.
Sorry.
Sorry. Not able to. Nitrogen cycle and Na is not available, like that number does not exist. Okay. Okay. I need to look into that one. I don't know what negative means. Like one would be nitrification, one would be denitrification, and the negative number, what does that represent? I'm confused with that.
Double-headed arrow, surely that's,
Huh?
but it's just double-headed arrow under the -109,
Yeah. So
then we can go in either direction, as you said.
decay and residue. Okay, it goes both side. Like, yeah, I'll take a look and tell you the negative, the significance of that negative. Okay, but this is entire the nitrogen cycle, like how they are. But the cycle would be closed down. Yes. Carbon cycle. So as of now, you can predict it. There are outputs and inputs on both sides because nobody asked us. That's why we don't have it in the SWAT check, but you get the outputs on the carbon as well. And we have a simplified model for the carbon module. Then we have SWAT carbon specifically just for the carbon. So you should read that paper, SWAT C.
Thanks.
Yeah, so that will explain you more in detail about the carbon cycle. And then third, we are working on improving carbon module and greenhouse gas emissions. So that would, upgraded version would be there soon. So C, C as the carbon,
And that's not good.
SW80. Sorry, SW80. God, sorry. Yeah. Yes.
Can I for arbitral values instead of being
Arbitrary values instead of this one. Where? For what?
like for the.
Okay. So we will see that tomorrow. We will edit a land use management, the entire table. And then so as of now, these values are general values, like we did not give it any nitrogen input. Okay, so SWAT assume based on the soil, it would assume some nitrogen values and it start the nitrogen cycle and it is giving you some numbers based on that. But if you want more detail, we will do that tomorrow. We will give it input, but rather than we will give it like how much fertilizer we are putting it there, and then it will use those numbers and bring outputs accordingly. Okay, so as of now, we did not do anything. So there are some default numbers, it is using those based on the soil characteristics. I think she had one question. I will go one by one. We're good with taking his roles. Okay. You had a question? Can you repeat again? Yeah. He said.
Yeah.
He can.
Yeah.
For the precipitation climate station, we use the centroid position. Note there are multiple methods available to like use distribute the precipitation data to different subbasins like
So
thick and polygon.
it uses the
Yeah.
fairly crude formula of
Yeah.
the
So-
nearest subbasin to the centroid of the subbasin.
So this part is we tested, like there was no significant difference. We used a complicated method to assign a climate station to subbasin. So that's why we chose a simple method, like centroid based. And because we keep the subbasin size relatively small, so if we do the complicated method, it would not improve the performance much. So why we want to complicate the things? Okay, so sorry.
You can complicate it yourself by generating smaller subbasins
Yeah,
and having more weather stations. I mean, if you have a very mountainous area where elevations are very different, then you might want to do that.
yeah. Especially like with the elevation range, left side comes into play, so that we want more stations and you have a question?
The simulation just that is like into the summary just for event measure.
Yes.
But I wonder how can I check the output for each year or each parameter?
We will check that later on. We will try to see today. Otherwise, tomorrow we will see that. Okay, we will reach there. Yes.
Is there any way to check out each visit, each
To see the results, we will tomorrow try the visualization tomorrow, right? And in that one, we will try to see for each subbasin spatially.
Yeah, we're looking for that today.
Okay, we can try today.
Yeah, sure.
Okay, we'll see that one. You have. Yes.
Should we after Mr.
So, question is there are many warnings when in the swam class, so which we should take serious, right? So all depends on your knowledge about your watershed. Okay. So as Chris said, those warnings are based on the average behavior of a watershed. If average behavior means like evapotranspiration would be the highest component, 60 to 80%, 90%. If that is not there, so it will split up. Okay, your evapotranspiration is bit low. So you should know about your area accordingly. So based on that, those warnings are just to bring your attention to the model, like this is unusual, and if that is your area, for example, phosphorus, right? If your soil is phosphorus rich, you don't need to provide any output, phosphorus as a fertilizer. So you can say, okay, my plants don't face a phosphorus stress according to the knowledge of your work. Okay. Anyone? Any additional query?
So you want to look at some outputs? Yeah? So if we go back to the project folder, you can see there's the folder called Watershed has got basically all our maps in it. One has got scenarios, and we got one scenario, which is the one you start with, called default. You may have noticed in the SWOT editor, there was an option to save the scenario. So if you called it run one or something, then you'd find there was a folder run one in here, and everything in default would have been copied to it. Okay? And that's what you want to do if you want to do one run with certain characteristics and then change to do a model based on, I don't know, the climate's going to change and your average temperatures are going to go up by a degree. What would happen? You can make another scenario, and you'll see later that we can use those scenarios and compare them. But when you do it as you run, it always creates the default scenario. And inside that, there are two folders, one called results, which has nothing in it yet. It has a few maps that are used in visualization, but there's nothing interesting yet in there. There will be later. Actually, no, sorry, I beg your pardon, because we've run SWOT now. So results folder contains a lot of maps that are used in visualization, and that database, SWOT plus output.sqlite. And we'll find once that database is created, then you have an option inside QSWOT plus to start visualization. But this is only created when you run SWOT. And if you rerun SWOT or SWOT plus, it would overwrite this database. The actual text files that SWOT uses or SWOT plus uses are in this text in out folder. And you can see there are lots of files. What would you like to look at? Aaron, suggest one. What's interesting? He's not going to. All right. HRU losses by month is what? A 12 megabyte file. I always remember, so I'm not going to look at that one. It's charged slightly. No, it's all right. Let's look at it. HRU losses per month. So for every HRU, for every month, it gives you a whole lot of numbers. Sediment yield, I guess that's sediment yield, something, tons per hectare probably. Sediment organic, kilograms per hectare, and so on and so on. And I can't really, and you can see it's, although a lot of the values are zero, as it happens. So all the data is there, but there's huge amounts of it. I always remember back in, what will it be, in about 2005, when I was first looking at writing this software, I spoke to a postdoc at a university in Canada. He said, SWOT is a wonderful tool, but all you get is a lot of numbers. So, and the database is essentially, why won't that close? A copy of this data. So we'll look at visualization. First of all. So if we go back, so what I'm going to do is I'm going to, well, in fact, you should do the same. You want to click OK on the main SWOT form, if it will do it. Maybe because I've still got the SWOT editor open, it won't, I've got to exit that first. Okay. Oh, no, in fact, it does it immediately. You don't need to exit it, right? The visualize option has now appeared because we've run SWOT, and so we created that database in the results folder. All right, and that means visualize is there. And that means if we close this project and start it again, or we go and do something completely different for the rest of the week, and then we come back next week to look at this project, then visualization will still be there because the database is still there. But you've got to remember that the database is only up to date as the last time you ran SWOT. I've just pulled out one. So visualization is my attempt, and it's peculiar really because it's my attempt and I don't use it. So I really only have to guess what people want. Anyway, this is what you get. So if we open visualize, then we'll see that there are basically, well, first of all, we've only saved one set. Well, we've only got the default scenario. We haven't saved any. It's got the dates from 93 to 2000. Where did you get those dates from? Well, we chose to run from 1990 to 2000, but we said the first 3 years are warm-up. So there's no data for those. All right, so the tool has just dug those dates from our options and chosen in the SWOT editor. So it's the whole of 1993, from the beginning of 1993 up to the end of 2000. And then we can look at what are called static maps and animated maps. Animation is an attempt to show how things change over time, which is the question you asked about. And we can plot some graphs, and we can do some calculations of standard numbers, which I probably won't do on this course. Well, they're not interesting for this watershed because it's too small. Right, so there is this pull-down menu at the top right, the choose SWOT output table. And these are named similarly to the files you saw in the text in out folder. And they're grouped according to periods. So all the first group were all the monthly outputs, because they all end in mon. The next group are all the annual outputs. So the mon files will have basically 10, well, it was in 3 to 2000, inclusive is 8 years, isn't it? So they would have 8 times 12, 96 values in them for each variable, for each HRU, or each landscape unit, or each aquifer, or each channel. Then, so these are the monthly outputs, and these are the yearly outputs. And then the last group are annual average outputs, so they all end in AA. So all time information basically has been removed from the last group. So you can choose which output you want to have a look at. So, go on, tell me, what output would you like to see? Water balance? All right, everyone answering at once. Let's look at LS unit water balance. So what values, if you now look at the choose variables option. Sorry, first of all, it invents a shapefile, which is named after the what you chose, but you can change that. So you may want to keep these shapefiles to look at them later, or because the attribute tables are useful. So we can look at, so if you click on all, you get all the outputs that are in this particular file, which is it was water balance, wasn't it? I chose WB. Is that right? Yes. So we can look at ET, for example, to see if how the ET varied. And then it's going to color a map by landscape unit, because this is a landscape unit output. If we chose an HRU map, with the HRUs would be colored. But we chose landscape unit. So it's going to color the landscape unit in each place with some number, according to some number for the whole period, right? Because this is a static map. So what's the number we choose for ET? The monthly mean? The maximum? Well, let's choose maximum. And you click create, and you get a map with right, so there's a key. So you can look at how the ET was distributed across the landscape units, which is not terribly interesting, probably. Let's draw another map. Look at sediment. I think sediment is in losses, is it? Yes. Where is it in water? Oh, yeah. Look at the sediment yield. Again, we'll look at maxima, and we get another map. That's rather more interesting. Because there are particular places where the sediment yield is much higher than others. So you might say, why is the sediment yield down there in the south so much higher than typically elsewhere? What's happened up there? And why there and there? What's interesting about those places? Right? So what the tool is doing is just using the landscape units or the HRUs or the subbasins or whatever according to the output you chose. And it's a static map for the whole period. So you have to choose whether you want an average or the maximum or the minimum. And then it divides it into 5 ranges to give you the best separation. Uses something called Jenks algorithm to do that. And if you choose an output that's based on a stream rather than a landscape unit or an HRU, like channel SD, I forget what's in channel SD. So you choose the output table. And again, click on all. So you can look at the average evaporation, for example, monthly average. And this time you get, I need to hide the other ones. Whoops. So I've only got, oh, it's still showing the HRU, so I should choose to hide that. You can choose what other maps you want to stay in the background. So there's a map of the, oops.